Hey there, and thank you for attending today's webinar on CIMCO Tools. If you're not familiar with CIMCO products, they make software that caters to the manufacturing companies and machine shops, large and small. Their products take manufacturing to the next level in all different aspects of a machine shop. And we're going to be discussing three of the most popular products that they have right now. And my name is Dennis Ungaranu. I am one of the many Mastercam AEs on the MLC team. I am out of the Houston, Texas office. And I would like to start off with showing you the Simco Edit Pro. So, have you had this problem here? You go to start looking for NC program and you got a folder full of a ton of files. And these are all NC programs that probably have ran on a machine before or have accumulated over time, over years, over decades. And this is only 400 files. I know I've seen thousands and thousands and thousands of files, and having to navigate through them all and figure out what's what is really going to make it kind of difficult. So, using Simco's Edit Pro, their editor allows you to open all these NC programs, allows you to edit, verify, you can backplot the code so you can actually see what's going on. And then there's a lot of search tools that help you navigate through the code and find information that you need, such as grabbing a quick tool list or just making a quick edit to some speeds and feeds, and then being able to just plug that into your machine. So let's take a look at that big old hodgepodge of files. And I'm looking at a couple files here. So let's say I want to grab this one here and this one here, and let's see what's going on with these. Now, over time, you might get better with numbering systems and things like that, which will help you navigate and find different files. And in this case here, it looks like I got a main and a sub program. So this tells me that this is kind of a dual stream program. And if you're not familiar with that, that's going to be on some of these sophisticated screw machines or Swiss type screw machines. So with that in mind, um, these machines run these programs that are synchronized, right? And we can quickly look at some information here. Well, there's a tool 22, and what's nice is there's a lot of navigating tools that really help you speed things along. So I can go quickly to the next tool, tool 5, tool 8, tool 6. I can always change this tool number if I need to. Let's say, yeah, well, this looks like it's a cutoff tool. It's not on 22 anymore, or 23. It's going to be on tool 22. And I can quickly make those edits on the fly. And I can also say, well, it's not going to be 4,000 RPM. We'll make it 3,500. Just slow it down a little bit. We have our feed rates, and the colors are really nice because it really helps distinguish the different types of information. M codes are function codes for the machines, and then this blue color, teal color is the feed rates, and that's kind of your cutting numbers for X and Z and all that stuff. We have some yellow stuff, and yellow a lot of times is like rapid moves or kind of setting up a position or things like that. So just really quick and easy. The greens are comments, so we can navigate through quickly. And if we look at, in this case, the NC Assistant, a really powerful tool here. And what's nice is I can actually run these in a multi-channels scenario here. So I have the main loaded on the left side and the sub program on the right side. And these machines run both of these simultaneously. So as you can see, it even has the sync codes lined up. And as I'm navigating through, it's also synchronizing my scrolling up and down. So it's keeping the program aligned and showing me what's going to be running as I'm checking and verifying the program. And then when we get towards the bottom, you can see there's a lot of synchronizing back and forth that's showing the program where it's passing, the syncs back and forth from the main spindle to the sub spindle and all these weight codes. So pretty neat to be able to do that quickly and easily, just from the native NC program. And what we're going to also do is we're going to look at a few other files. So we got some files here where there's looks like a Rev A and a Rev B and a Rev C. I don't know what that's going on with all these, but it looks like they're all the same part number. So what's going on here? We'll go Rev A, and I'm looking at this one, and I'm going to start scanning through, and I can see, okay, tool 1, 2, 3, tool 1, 6, 8, tool 1, tool 6, tool 8, tool 1, 6. Okay, that's a repeat of changing tools back and forth over and over. That does not look like a program I'd like to be running. So I'm going to look at Rev B. Rev B, oh, that looks a lot cleaner. And when I look at this one, we can see tool 1, tool 2, tool 3, tool 4, and there's a lot of moves in between. And these are drill paths or drill tool paths, so you can see how it's got the drill cycle in there and then just all the different locations and positions where all the holes are going to be drilled. So very nicely, I can scan through the program all the way to the very end and kind of see what's going on. Now I got a Rev C, and this looks very similar to Rev B. So what is the difference? Well, what's nice is that we can quickly use file compare. So anytime you have some files, some NC programs, we can compare with the window here. So I'm going to take my Rev C, I'm assuming that's the final one. I'm going to compare it with the window, and I have A and B open. So I'm going to click on B, and we can see that Rev C has different feed rates and different spindle speeds or RPMs than Rev C or Rev B. So Rev C and B looks like it has a lot of different feeds and speeds. All right, so Rev B, maybe we were a little too aggressive, maybe we were a little too ambitious, and then Rev C, we're like, all right, let's back things off, let's make it more conservative. Maybe we needed to let those tools last longer a little bit. So looks like we backed off those feeds and speeds. Quickly, you can see that, and then end the file compare and now move on, right? The other nice thing about it that we have is anytime you have all these numbering, the end numbers, you can always remove those block numbers. We can quickly select all and just remove block numbers or add them again. So really quickly we can do that. You can adjust your feed rates and spindle speeds. Let's say I want to increase my entire program by 110%. You can do that. Let's go 110. And then this RPM right here, 3,500, should be increased by another 10% there. So 3,850. And that should have also increased this one and this one. So all of these should have increased just a little bit. So that's nice to do. We can always adjust our feed rates as well. And there's just a lot of different tools that help you out. But backplot is the key. Now backplot shows us something that we can't see. Now some of you might have this on the machines, but then what do you have to do? Load up NC program in the machine, run your graphical interface or graphical preview, and basically does the same thing here, where we can run all this, and even better, it actually gives us kind of a tool that we could use because it knows it's some sort of a tool. Now, if you want to get fancier and better at this and more accurate at what's going on, well, because we have all these comments here, we know what size drills we're using, right? In this case, we got a spot drill, and we look at the top here, and we can see that we have a 1/2 inch 90-degree spot drill. So you have all your tool numbering here and description, So you can go to your tool setup and we can change all that information real quickly. We got drills here, some end mills, and we can also add tools that are, if there's any missing, this is from the library that Simco has. And you can take drills, end mills, countersinks, holders, all kinds of things, taps as well, throw them in here, number them, and then you're good to go and it'll simulate that. So pretty nice, just part of the editor itself. So very nice to be able to visualize what's going on with this NC program and this crazy amount of code that looks like a foreign language to me. And 1,795 lines. I don't know if I would want to go through and read all that. Yeah, I don't understand. This is like some sort of alien language, right? So looking at the back plot, and that's definitely going to help visualize what's going on. And when you have this situation going on, now we can deal with it a lot more effectively. All right, so now let's take it over to the next level, into Mastercam. So as we're programming with Mastercam, and we want to visualize what's going on. Now, Mastercam has the backplot function, which works great. It also has the verify. And when we load a verify, you can see it processes the NCI data, loads the verify, and then we can visualize what's going on. Now, when I hit play on here, it does kind of take a little bit, right? And it's a little bit jittery, and I have to kind of play with the scroll wheel to see what's going on. And one thing that Simco does is they've taken this verify and they've optimized it and streamlined it. So you can take this program, and instead of running Mastercam's verify, or the way I like to do it is, the more tools you have under the belt, the more options and the more uh I guess opportunities that you have to catch any sort of mistake, right? Any sort of human error, or any type of error that has occurred, or software type error, anything that is going to happen in the software. We want it to happen in the software. We do not want it to happen in the machine. So we can go to Simco Verify, and Simco has the quick verify feature. So it is very similar to the verify for Mastercam, but as you can see, that thing loads practically instantly in a fraction of a few seconds. And on top of that, when we run this, I mean, we can see how it's much smoother interface. They've optimized the kernels that drive the simulation and the models and all this stuff. So it is a much better simulation and much smoother, and lightweight compared to the one that we have in Mastercam. So again, we're taking things to the next level. We're able to speed up our verification process. Or if you ever have a question, have you ever ran verify and you ran the back plot and you're like, I'm not sure if the verify is showing me what I thought I was gonna see, and the back plot seems like it's showing me something different, and I don't know who to trust. And here's just another layer of confidence. You can use Simcoe's Quick Verify, and we can actually eliminate those questions. We can say, yeah, all right, well, the Quick Verify is doing exactly what Mastercam's Verify is doing. So perfect. Okay, it's good then. And as you can see, we also have the table here. We have all the fixturing and all the tools brought in from Mastercam real quick. We also can show the entire machine itself. So it's got the full machine simulation. And if we want to just run it just like verify, we can turn off machine simulation and just let the tool run around just like normal verify in Mastercam. We also have the colors. You can increase the quality on the fly. And as you can see, running the tool as it's running, we can always do stop conditions on collisions or anything like that, just like the verify. But when we turn on machine simulation, we can turn that on and off instantly. We can also run the program and visualize things like this. And we can actually see the machine and the trunnion rotating, make sure we have the clearance with our holder, make sure we have the clearance with the spindle, that nothing's hitting there as it's machining the part. And it's when it does its rotations, we can also see that as well. Pretty neat. So we're able to visualize what's happening, and then now we know what to expect when we go to the machine and something like that is happening, and we don't have to freak out or press the stop button just because I didn't know that was going to do that, right? Well, now you do. Now you can see it ahead of time. Okay, so that's Mastercam's quick verify, and you have all the same tools just like the verify here. We can do compare, and you can say what range do you want to compare, and it'll run the compare here. Let's just show our piece here, so we can look at the compare there, so we can see everything that's in green is nominal. Anything that's towards blue, as you see the bottom, it's got extra material for op 2, that's going to be blue. And if we cut a little too heavy, it's going to start turning, red. So everything looks good. And if I turn off the stock here, there we go. So it's all green, nice and bright. Okay, you can do cross sections as well, which is really neat. So if you have holes or any ID grooves inside bores or anything like that, we can quickly look through, and we can always move this up and down, and we can do real quick cross section examination here. So pretty cool, quick. You saw how fluid this thing runs. It's very nice and smooth to work with. And then the more you get used to it, just the better and faster you'll be. All right, so now we did see the quick verify, but why machine simulation? Why is that different? We did see the machine, we saw the simulation. Well, here's the thing. I want to be able to verify the G code, right? And Simco does G code simulation. So now to close the deal, from verifying NC programs, verifying our Mastercam programs in a faster, more efficient, quick verify. Now we're ready to post the program, but I want to verify the posted program. I want to verify how my machine is going to run the posted program. So being able to do all of these things here and reducing any type of errors, we have the same part on the screen here in Mastercam, and all we're going to do is, instead of running the quick verify, which we already did, we're going to run this in Simco Edit, and it's going to post out the program. I'm going to go ahead and post out the CNC program, and it's automatically going to toss it into Simco Edit and load the simulation, the full machine simulation. Okay. So as you see, we can turn on the entire machine. We can see all this going on. We can turn it off. We can visualize everything. What's nice is that we actually have the code on the side and it's interactive with the simulation. As I click through the code, it actually moves everything around. And if I go ahead and hit the play button, it actually runs the code as it's simulating, just like it does in your machine. So here we're just probing and getting our work offset going and setting our Z height. And it looks like it stopped, so we're going to go ahead and continue. I don't think I have a tool change on, so we'll go ahead and continue. And it's running. And you can see it running through our program. The other thing, to keep in mind is that as we're verifying this is true G-code simulation. It's checking the code, it's running the code against this type of machine. It's using the kinematics of the machines. And when the machine is built out for you, we can build that machine for you. You could try to build it yourself as well. There is a machine builder that you can try to do. But as you can see here, it reached the Z limit. Okay, so you can set limits to these machines. Okay, and it'll reach different limits and it'll stop if you set that condition to stop when it reaches those Z limits. But the beauty of it is, of course, seeing the rotation, seeing all that occur, making sure that we have the clearance with the spindle and the trunnion that you have, or if you have a gantry type trunnion, same thing. There's a lot of fixturing in play, there's housing in play, sheet metal in play. So we need to make sure that our program is going to run without errors, and when it gets to the machine, then we're not going to have any issues there. Okay, so really cool motion, just like you would see on the machine. And as it's resetting the rotation, we can see all that, and our program is done. And then there's our business card holder. So the benefits are astronomical. I mean, just being able to avoid a collision or visualize it and see it here in digital form doesn't cost you anything. When it happens on the machine, that costs a lot of money in downtime, in costs, repairs, tooling replacement, machine parts replacement, and of course, the downtime and the loss of revenue, right? So, one saved crash pretty much can pay for this, and pays for itself in one instance. But you'll be able to use this over and over and over on these machines, and it's great not just for 5-axis machines, but if you have a standard 3-axis vertical mill with a 4th-axis rotary on there, again, you have this big unit that's sitting on the table, and there could be potential issues for clearances. Depends on also the type of part and fixturing that you have. So real quick, we can always go back with the same program and we can backplot it. And it loads our fixturing, it loads our tool, so we can always visualize through our program. And as I click in this program and I say, well, I see a code here that I don't recognize. Where is that at? Oh, I see. It's in this section here. Okay. So we can always click here anywhere in the program in the NC code, and it'll launch the simulation or the backplot forward to that point. And we can obviously edit anywhere here. I can say, oh, the spindle needs to be backwards. We're gonna go MO4, and then save the NC code. If I make a change here and I accidentally make the wrong change, or if I say instead of negative 1.025, and I go negative 1.050, well, that's a bad number there. I lost my decimal point. I didn't put it in. I didn't realize I accidentally deleted it. And as you can see, it shoots that tool 1,050 inches down south through the machine, through your floor. And that's not going to be a good time. So, real quick, we can fix all those errors and we can see that and visualize it as we're editing through the program. So, very, very beneficial. Usually with the Simco, the best thing to do is just get the bundle. You get the full editor, the quick verify, and the machine simulation. And then as far as machine goes, just tell us what machine you have and we'll look and check availability. Most of the Haas machines are already pre-built and a lot of them are available. And we can help you with any machine that is not readily available. We can build that out for you and we can customize that for you. You can also grab all the sheet models from your manufacturers and then we can take that and plug that in to make sure it's an accurate representation of your exact machine that's on your floor. So real nice. Simulation, the simulator, the editor, the quick verify, one big bundle, saves you time, saves you money, saves you from crashing, and just makes you more efficient, effective. And the important thing, build confidence for yourself as the programmer, to build the confidence that your programs are good, and also the operators, if they're able to visualize this, if there's a way that you can show them the program, then they're able to understand what to expect when the machine is running and how to set up their tooling or how to set up the job and everything, the fixturing and all that, because they can visualize it and see it all in the machine just like you would be inside the shop running that machine. We have all these products on our website. So if you go to the cam and go to Simco, you can see we got the editor, the verify, the machine simulation. There's some videos that show you a little bit more. You can share that with your coworkers, with managers, or anything like that. There's some more information about the different features. And some of the other products that Simco has are the DNC, which is a machine communication software that helps you to transfer programs to the machine. Um, you can have a pool of machines or work cells or things like that, and then you can have everything set up and it could go through wireless or wired, and you could even send programs to at different facilities and things like that. You also have their data collection, real-time machine monitoring. Pretty cool if you like seeing what's going on with your machine, running lights out, running second, third shifts, seeing if that machine's idle or if the machine's down, with dashboards and reports and even quantities of parts that are counted and showing that you ran this many overnight and things like that. You also have some document managers. There's an NC program, NC based type document manager, or their MDM, which manages a lot of the programs and files that pertain to the jobs. So you can you lock out a file if you're working on an NC program. You can lock out a file if you're working on a Mastercam program. You can set up tool lists and pictures and have it pertain to a specific job. So pretty cool there. The other one is a maintenance system. We all got to have those PMs going, right? We have standards that we got to keep up with, and a lot of those standards require some sort of maintenance system on those machines, and the machines as well require maintenance from the manufacturers. So being able to keep a track and a record of all that, they have a great software for doing that. And if you need some sort of production planning, if you're running high volume production, or you have work cells with machines and you want to load up jobs on those machines and cells, and however you have things laid out on the shop floor, you can do that and do scheduling and order tracking, so you can see what the workload is on each machine or maybe work cells, and you can shift things around depending on the workload that you have given to those machines and what's really happening in the shop. And then they have some other software like CNC calculator. It's kind of like a basic CAD type calculation, and it lets you do a little bit of geometry and drawing and things like that. And then some other software that, again, with communication or secure remote connections and things like that, plus their e-learning solution for their Simco products. If anybody else has any questions, then we're going to open the floor to you guys.